in a 2, yeah, go ahead, head in a 3, head in a 4, head in a 5, and a head in a 6, okay? If I have a head, if I have a tail, again, tail on a yes, and a 2, right, and a 3, good, 4, 5, and 6. And this is the only way that these can occur. You agree? Now, I'm looking for a head in a 3. These are my total possible outcomes. How many is it? Well, it's 12. How many ways can my event happen? My joint event. Two possibilities. 2 events. A head and a tail. Excuse me, a head and a 3. Well, it happens only one time. So the probability is 1/12. Now, this is the key word. A head and a 3. And you know you're going to multiply. Okay? The complement of the event is everything that is not the event. As defined by your book, it is includes all events that are not part of A. So the complement of a head is a tail. Okay? Complement of a head is a tail. Complement of a 3 on a die is 1, 2, 4, 5, and 6. So complement of a head is a tail. Complement of the 3 is 1, 2, 4, 5, and 6. This is everything that is not the event. So if you include the event, you have your total sample space. So 1, 2, 3, 4, 5, 6. That is the whole sample space. Now, and if you have a head or a tail, when you're flipping a coin, those are your only 2 possibilities. Oftentimes, this is written like head complement with a little check. Head complement with a little check. Or probability of 3 complement. This is how it would be written statistically. Probability of 3 complement. Okay? And these are just terms that you need to know. And sample space is all possible outcomes. All outcomes. So again, my sample space is generally given by French brackets. Your sample space for a coin is a head and a tail. A sample space for a die is 1, 2, 3, 4, 5, 6. Okay? And the sample space for my joint probability of a head and a 3, a die, again, that was head 1, comma, dot, 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 head 6. So head 1 and head 2, or head 3, head and a 4, head and a 5, head and a 6. And again, a tail and a 1 up to a tail and a 6. So those are all my possibilities for my joint probability. And these are just definitions that you need to know on page 150. Now, throughout the chapter, we're going to be talking about people who purchased a large screen television, people who purchased a DVR or a digital video recorder with that large screen television, and we're going to look at that as we progress through probability. We're going to keep coming back to this example. So the first place you're going to see that is on page 151, and I'm just going to take a second and put that table up here. Yes, no, okay, and I'm just putting I'm just putting exactly what you have on page 151. Yes, no, total 200. This is again total 250, 750. Oops. 250, 750, and 1,000. Okay, so now we're up to speed. Now, what we're looking at is, I guess it started on page 148, but what we're looking at is people who went to the store planning to purchase a large screen television and people who actually purchased a large screen television. So sometimes you go to the store and you plan on buying something and you buy it. Other times you go to the store, you plan on buying something and you don't. Sometimes you go to the store, you don't plan on buying a television and you do. And those are the days you go home and you think, what did I just do? And sometimes you don't plan on buying and lo and behold, you don't buy the television. And so that's what we have working here. Now, if you follow the flow chart, people who plan to purchase, did they purchase? Yes. So 200 people who plan to purchase actually purchased. There are 50 people who plan to purchase. Yes, they plan to purchase, but no, they didn't purchase a television. For whatever reason, price or something, they didn't find the model they wanted, they were sold out, whatever. So, yes, they planned to purchase, no, they didn't purchase. Okay, then we have plan to purchase. There were 100 people who did not plan to purchase, but who actually did. And we have 650 people who did not plan to purchase and did not purchase, for a total of 1,000 people. Okay, and in this table, if you look at the simple probability here, you're going to see a simple probability is people, the percent of people who purchased, or the probability that someone purchased a television. Simply, the probability of a purchase is 250 out of 1,000. Okay, probability of purchase. The probability of purchase complement would be 750 out of 1,000. Now this would be simple probability. Okay, simple probability. Now, if we wanted to look at something a bit more complex, we can go into joint probability. Then we can look at the probability of two events. Okay. What we're going to do in a joint event is on page 152. Okay. On page 152. Okay. I'm looking at page 152. We have another contingency table. Purchase a DVR, yes or no. Purchase a plasma, yes or no. You can see we have 300 people that we're looking at. 108 of the 300 purchased a DVR. So these are the 300 people who purchased a TV, and 80 of the 300 purchased a plasma TV. Okay, and we can look at the joint probabilities. Now, if I was going to do a simple probability, which is shown on page 152, you would do the probability of plasma. Well, that's 80 out of 300, or 26%. Okay? That's the probability of plasma. Out of all TVs that were purchased, all 300 TVs that were purchased, 80 of them were plasma. If you want to look at the joint probability, Did someone purchase a plasma? Did someone purchase a plasma? Yes, they purchased a plasma. And yes, they purchased a DVR. Okay? Purchase a plasma and yes, purchase a DVR. You're looking at this number, 38 out of 300. Okay? 38 out of 300. This is, let me erase this bottom part. This is the probability of plasma and DVR. Okay, 38 out of 300. This is a joint probability. Okay,